What's up, y'all? Jesse Warden here. Today we're going to go over 2D platformers. We're going to make a character run and jump both ways, left and right. So if you're familiar with Mega Man, Zelda 2, Super Mario Brothers, all those type of games, we're going to do it today with Box 2D. Why Box 2D? Well, there are some who say that when you use Box 2D to do 2D side scrollers, that it's more trouble than it's worth. I'll point out some of the reasons why, but for the most part, it scales very well for simple games, meaning you don't have to handle the collisions, you don't have to handle the walls, all the collision codes handled for you, you don't have to scale it, you don't have to do meta-tails, all that other weirdness. So I'm just going to show it to you in Corona using Lua, Corona SDK, and you can apply the same concepts to Cocos 2D or anywhere else Box 2D has been ported, C++, whatever, okay? So we're going to start from scratch. I'm going to borrow some code that I built in Tholdane and Maestro. I'm going to open up Corona Terminal. Make this a little bit bigger so y'all can see it. And let's make a directory real quick. Let's open projects. We're going to call this run and jump. Make a code folder as usual. Alright. And we're going to save this guy as main.lua. Then we're going to open it up in the Corona emulator. It should show just a phone for now. What I'm going to do is I'm going to copy code, because it's so much easier to copy code from an existing project. Basically, like I said, a template files to actually speed up your development versus having to do the same thing every single time. So don't worry about this second window. I'm going to snag some things that are relevant, okay? The first is build.settings, which is mainly for iOS. It allows you to deal with certain orientations, portrait, landscape, etc. When we save this, the emulator will actually detect that we want it to be rotated, so I will move it and never touch it again. Cool. Next up is the config. This tells us how big our screen is. We're going to make it a little bit smaller here so you can actually see what we're dealing with. We'll do 320 by 640, okay? 60 frames per second because we like it smooth. We like it fast. We like the refresh rate really fast. Wing Chun style. You know what I'm saying? All right. Then let's get ourselves some copy-paste physics. Okay. We're going to grab ourselves a global variable of stage. Going to grab, what else? Let's grab some physics code up here. Now, notice there are three things for Box 2D, which allows us to debug our objects, okay? We're going to do the debug one, and the reason we're doing debug is we want to see just the geometry, the squares, the bitmaps, the vectors, whatever. They're going to draw the boxes of what they represent as a body or an object that can be collided with, okay? The only difference between this from the default is, I believe it's 8. It just means it's a little bit more accurate in determining collisions, okay? So let's snag... let's make our first function. So when you're dealing with Box 2D objects or physics, there are three different types of objects. The only two we really care about today are dynamic and static. Static means it doesn't move, it sits there. It can be affected by things, then you can bounce off of it, but the object itself is not going to move. You got it? So it's going to stay there. Perfect examples are floors, walls, ledges, things of that nature, right? So we're going to make a utility function, aka a factory function, aka a local function that returns something. Let's make it global. Say get wall with a width and a height. Instead of calling width and height, we use W and H because using single letter variable names is bad practice. And I want to be a rebel. Oh my gosh, Jesse, that's just so... I don't even know. It's shocking. All right, and we're going to do physics.add body of this wall. Okay, to be static, right? Like a static stretch. Static. And that's a horrible analogy. It has nothing to do with a static stretch. Static stretches are good for you, though. Especially if you're a programmer and don't sit all day. Me, I work out. Most programmers, not so much. Don't forget, vitamin D deficiency, also a bad thing for programmers from a health perspective. So, we now have a wall. Let's test it. Let's see if we can get a wall. I would like a floor, please. Oh yeah? Well, how big is your floor? It's 700 wide by 30. Notice the height is not 1 pixel, but is 30 pixels. Now, why do we make a floor so thick, or a wall? Box2D has pretty good collision detection. For speed purposes, it does some approximations. So what that means is if you have a really fast body or some very complex interactions, the actual body might go through the wall, right? So the way you fix that is make the walls thick, Texas style, big, right? So make it thick. All right, so we're going to test this wall or floor, and there it is. Now, floors are typically on the floor, also known as the ground, also known as the bottom, not in the sky. So let's move it down. Unless you're playing Zelda in that bird version, whatever that version is. Staged out height -30. Ta-da! Just kidding. How about staged out height? There we go. Good enough. Then we're going to do another one. We're going to call this wall left. So wall 1 equals get wall. We're going to make this one 30 wide by 700. And we're going to put this guy basically where he's built. See, now, so on the left right here. Okay, pretty cool. Make wall 2. Put this sucker on the right. Wall 2 is staged out with -30. How about 15? Perfecto. I like it. I dig it. I'm enjoying its current position. That is fantastic. So we have a little bucket. We can put our character. What is a character? A character, for this part, for the most part, I'm going to show you 2 examples of characters, okay? The other one's a little strange, and I'll explain later why, but for now, we're just going to use the normal box. So we're going to say get character, or get player. Another global factory function. A rect, a new rect, 0, 0. We're going to make him about 30 wide by 60 tall, okay? A normal rectangle. We're going to do something special with this guy, and I'll explain why in a minute. I'm going to comment it out so you can see the effects of it. So a character is going to be a dynamic. Now that's the default value for add body for most physics engines that utilize Box2D, whether Lua, C++, whatever. For us, we're going to hard code it to dynamic so you know the difference. Dynamic means it will move. It will be affected by gravity. It will be affected by forces. It can be affected by rotation forces. Blah, blah, blah. Okay, we're going to return it. And we're going to create a player. We're going to say player equals learn how to spell Jesse Warden. Get player. Okay. Now he's going to fall down and bounce. Cool? You got it? So that little brown thing's our player. Now you'll notice, why is it brown? Well, when you're doing debug mode in physics up here, greens are static pieces of geometry. Regardless of what the bitmap is, regardless of what color the vector is, they're going to be green. You're not going to actually see them, right? That's what's so great about Box2D debug. Brown means that, like brown color, it means an active dynamic object. When it turns gray, it means no longer are collisions constantly being detected. And this is different from the isBullet setting, which means really check for collisions a lot, right? So that's all that means, okay? That's what those colors mean. And they help you visually debug. That's why it's called the bug. You take those bugs and get them out of there. They're bad, man. You gotta kill them bugs. The only good bug's a dead bug. I'm doing my part. All right, so we got ourselves a player. Now, let's talk about what we want this player to do. Let's make him walk. Now, for now, we're not going to create any buttons. I'll do that in a minute. But notice something here. This is a piece of geometry, all right? And it's affected by gravity from all types of forces. So what we're going to do is actually move its X. Now, what's interesting about the way that Corona has implemented Box2D is that you can treat normal display objects and let them be affected by normal Box2D physics without having to really do anything. So for example, I can move its X and Y properties and it'll take that into account. It won't translate that to a force, but it will actually move the object. And if something's in its way, it'll move it out of the way. If it's lighter, if it's a static wall, it'll stop. It will, like, I would like to move right, but I can't. There's a wall, right? So it compensates and handles all those rules pretty well. So let's treat it as such. I'm going to open some older code, and I'm going to show you this open player from an older game. and I will show you what happens when we move it right, okay? So we're gonna do a normal game loop style way of doing things. I can use it. You can use inner frame if you'd like. That's fine. We can do that as well. I like game loops strictly because it's a little faster per device. So every single device will get the same amount of refresh. What that means is same performance. So if a slower device, it'll still refresh at the same speed. It won't run slower, right? And that's very important. So let me copy over that class real quick. I'm not going to put it in a package. I'm just going to make it simple for y'all. So call it game loop. Lua. Okay. We're going to go to the top here. I'm going to copy the same in code from up here. We're going to call require game loop. And right below stage, we're also going to put it there. You don't need to do this because it already is an implied G or a global. Okay. And we're going to go down to our player. And so whenever we get a player, we're going to go game loop.add loop, which means that it is now capable of receiving the tick function. So let's make the tick function. As you can see, Corona's already mad at me. Milliseconds passed. That just means how many milliseconds have passed since the last game loop. So you know how much time has passed. You can compensate if you would like. Reload. What's it called? Tick value on... Yeah, I know. Let's do it down here so we don't confuse it. Let's do it after we define the method. That way Corona stops whining at me. Cannot pass. Oh, whoops. It's not a rect. It's a player. Okay, so now it is receiving the tick function. What does that mean, Jesse? It just means that every tick or enter frame, we will know how many milliseconds have passed since the last one. You can utilize this in very efficient moving algorithms. For now, it's running at about, 30 or one chunk of a frame. So what that means is about 15 milliseconds have passed per frame, okay? So we're going to do all kinds of things with that. But first, let's define our move method. So we're going to say player move. Let's add some spacing so it's a little bit more readable, since Lua is a unreadable language. Oh, am I a bitter ActionScript 3 developer? Yes, I am. I bear it with pride, because at least I didn't defect to Java like a lot of my comrades. All right, so not that there's anything wrong with Java. All right, so what does move right mean? It merely means that we have a direction property, and it can be one of three states. Nil. It can also be right. It can also be guess. It's not metric. Left. That's right. Well, it's left. You know what I mean? So it can be one of the two. So if we move right, we say self.direction equals right. Okay? So if self.direction is right, what does that mean? It means if self.direction equals nil, then return false. Don't do anything. Abort. But if it is not, if self.direction equals right, then move, sucker. Now, how does it move? Well, let's define a speed here. How fast do you want to go? 1 pixel? 1 pixel sounds great. We're not going to use milliseconds pass now. We're just going to use a frame-based mechanism, and that's okay for teaching purposes. However, those of you who have experience doing geometry and trig and all that other math stuff, hopefully you paid attention in school, because this stuff is awesome. But not when you're a teenager and you don't know about this stuff, when you're young, and whatever. We're going to say self.x equals self.x plus self.speed. Now, what does that mean? That means when the move right method is called, it's going to set the player's direction to right. Now, every frame, the player is checking. Does my direction equal something other than null or nil? If it does, let's do something. If it equals right, let's go ahead and move to the right based on our speed. So every 15 milliseconds or so, it's going to add number 1 to the x. So it's going to add 1, 2, 3, 4, 5, and it's going to keep moving the object to the right. Assuming it's allowed to. Again, Box2D handles if we run into a wall or everything else. We don't have to worry about stopping, seeing if we're at a ledge, blah, 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 that kind of stuff, okay? So we're going to handle all of that ourselves. Relaunch. Okay. Now, how do we trigger move right? Well, for now, we're just going to do a normal, let's see, a normal touch handler. I'm not going to make any buttons. You know what? I probably should make some buttons. Let's make some buttons. What is a button, Jesse? A button is really just a piece of vector or bitmap geometry that accepts a touch handler. For us, all we care about is a box. So let's make one. Since I don't have any code, I can borrow. Well, actually, you know what? I should have a button. Do I have a button here? Climb up button, move right button. That'll work. Let's do that. Let's borrow this. Let's say get button. A button should be around 60 pixels or larger. The reason is that some older Android devices do not have a very sensitive touch area, right? The screens themselves just aren't as good as what? That's right, iPhone. So you should always make it 60 so it can detect the hit area and it's large enough for the user. 60 pixels is kind of hard-coded. That means on larger resolution devices it would actually be smaller, but those higher resolution devices are more capable of detecting a touch on this button. So for now, we're just going to go 60, okay? Rect 0, 0, 60, 60. Rect set fill color to, I don't know, red. Even though we're in debug mode, you won't be able to see it. That's okay. So what we're going to have to do is change this up here. I'll show you in a minute to hybrid. Why hybrid? Well, we want to see the Rex, but we also want to be able to see our button because button is not going to be a piece of geometry. Okay? So we're going to say set fill, turn rect. All right, so we're going to say down here, let's get a button. Let's say local move right button. Okay? Let's give our move right button a touch handler and say if the event, that phase, is ended, then we're going to call player.moveRight. Let's do it in began, and I'll show you why. We got to make a way to make our player stop moving. That's all right. I'll show you how it works first, then we'll fix it later. Return true, just let it know that we handled the mouse event. This is optional. You don't have to do this, but it is a good practice to do when your application gets larger. Okay, so we got ourselves that. Now let's add a move right button. Add event listener touch and move right button. We'll handle the touch event handler. Okay, so just to recap, we have made a utility function that returns a rect, or a piece of vector geometry, but it is not added to Box2D. Nowhere in here as we add in physics. It's strictly just a red box up there, okay? But it does, as you can see down here, listen for a touch handler. So when we touch, we're going to handle it and say, hey, if you pressed and you let go, then I want you to call player move right. And that will start the sequence of set my direction to right, tick, we'll detect that in the next tick, and move things over. Ready? Here we go. And there you go. So it's moving to the right. We have a character moving to the right. Now notice the X and Y is not really a force, it's actually moving the geometry. So it's not going to detect as a force. Also notice when it hits the wall, it stops, right? So all the collisions are handled for us. Now you can detect those collisions as well. The fact that it's moving by an X and Y versus using a force doesn't matter. Box2D will still detect that as a collision, and you can do what you will. Okay? So let's make it so we move it and then we can let go. So when you press a button, it has a began phase and an ended phase. There's things like cancel, but don't worry about that. So we'll say began, move right. And when we're ended, else if event.phase equals ended, then player.stop moving. Also return true. Let's talk about stop moving. What is stop moving? Anybody remember our if, then, and maybes? This is why I hate like dynamic languages with booleans, because they're not really booleans, right? And it's even worse in JavaScript. It's like true, false, undefined, null, and you can even overwrite the prototype to make it smoke dope. It's just ridiculous. So let's see, self.direction. Where was I? Sorry. It just drives me crazy, that's all. It just drives me crazy. It's not else if, it's else if. There we go. So now what happens is if I press it, it'll move, but if I let go, it'll stop. And the reason it stops is that when I let go, it says stop moving. Stop moving says take my direction set it to nil. If it's nil, I abort the function and do nothing every tick or every frame or whatever you want to call it. Okay? Now you can adjust that time that's passed, multiplied by the x for some differential of speed to actually make it move smoothly, but no one cares for demo. Okay? So I press, moves, I let go, it stops. Pretty rad, right? Jesse, that's amazing. All right, let's take on jumping. Is it jump from the Van Halen style? Or is it jump like House of Pain style? Definitely House of Pain. Now, I'm not saying I have anything against the 80s, but I was a kid in the 90s, and you know what I'm saying? Like, the club got crunk when they did that stuff. Alright. So, jumping. Right, jumping. So, jumping can be done a variety of ways, and it's quite challenging, actually, when you're dealing with, basically, how do I say this? With Box 2D. There's the reason why a lot of people don't like to use applied linear impulse for jumping in Box 2D is that it is a momentary jolt. It's kind of like if you remember shooting barrels that are explosive in just about any video game nowadays. Half-Life 2 is a perfect example. It makes other things, get blown away. All those, things in Japan where they take pictures and people are like, whoa, like they're doing Dragon Ball Z stuff or whatever. It's a momentary jolt. There's two types of those kind of forces in Box 2D. There's the momentary jolt, which is an impulse, right? It's like a pow. And then you have the other one, and I'll show you actually in the docs. Move it right here so you guys can see. Docs Corona. If you go to the SDK, I haven't had enough coffee today. There it is. So we're going to use apply linear impulse. If you're going to do a linear velocity, it's kind of like a jetpack, okay? So we're just going to do linear impulse right here. Cut this out. We're going to say player jump right, okay? So self dot, I'm going to do it like this. Let's do about 1 and 5 just to start. And we're going to apply that force in the center of the object. Now, notice that display objects in Corona SDK are from the center, right? That's where the registration point is. When you say it's X and Y, you're referring to the center of its geometry, of its bitmap, of its sprite sheet, whatever. It doesn't matter. It's in the middle. So when you apply forces in there, it's going to move directly to that. If you apply it to something on the edge, it'll actually make it spin, right? And this is bad. I'll explain why in a second. So we're going to do another one. Let's make it jump right instead of move right when I click it, okay? So here's what happens. It's going to apply a force of about 1 and a force of about 5 to up, okay? So it's going to move a little bit to the right. Now, as you can see, it launched like a rocket to the moon because we used a very powerful thing, and that was awesome. All right, let's lower it down a little bit, relax, not make it so strong. That was an awesome jump. There we go. Right? So that's jumping. Now here's the problem with linear impulse. Linear impulse doesn't care where the body is or where it's going. It'll actually calculate its forces in motion. So you can jump multiple times while you're in the air, right? That's the problem with it. Is you get all kinds of weird effects like that. Where it's like doing that, it looks something out of like Tales of Symphonia or something. So anyway, that's linear impulse. Notice if it bounces, that's you're gonna keep all the physics and everything else, right? So that's one way of doing jumping. The other way is to actually start a timer and move it manually with code. You can turn off the gravity for that particular thing by just setting the X and ignoring where it goes. You can change it to kinetic, which means it's not affected by gravity, just forces, and then move it manually with code. That's another way to do it. But for now, that gives you, a general idea of how we're going. So let's make it probably about 2. And keep in mind, these numbers are all affected by a variety of factors, such as density of the object, the size of the object, and the friction of things that it's around, right? And that's another problem, is that it depends on what it's touching for it to actually affect those forces. Let's turn the bounce down just a little bit on this wall here. Let's go. So you have a little less bouncy floor, okay? So the density is about, let's try, I don't know, stone or something. Friction's pretty high. The bounce is really low, okay? That should make it not bounce as much. Well, the object itself is still bounced. Let's make the actual player do the same thing. Okay. There we go. All right, so that's his jumping. It's a little heavy now, so we're going to have to make it a little bit more powerful. Let's try 2 again. See if that makes him jump to the moon. Yeah. I have to try 4. Let's go back to 4 when he was light as a feather. Okay. Let's try 10 and 40. Now he's made of metal. It's like Metal Mario. There we go. Let's try 80 and 20. There we go. Let's try 180. Still give it a little push. Okay. So we're going to do about a 60 and about a 250. You just got to play with the numbers until you get what feels right. There we go. Let's make him go a little bit higher. A little bit stronger to the right. There we go. That's a pretty good jump, right? Now, let's implement some obstacles and show you what the problem is when you get when you jump with a non-rotational object. And this is what I was talking about at the very beginning. So we'll say get box, local rect, display.new rect, 30, 30, and the rect is also a dynamic object, but we're going to copy some of this stuff and lower it down a bit, okay? So the density is not so dense. It's more like, I don't know, wood or something. And friction, 7's fine. It is a little bit bouncy, okay? And turn, get a few boxes. Say box 1. And we'll set him over to the right about, I don't know, 60. Relaunch. I fixed the code. Trust me. Oh, doesn't like line 36. Let's go fix line 36. Too many parentheses. I must freak out. All right. So as you can see, there's a little box right next to him. So watch what happens when you jump. Right? Oh gosh, I fell. Ah! So that's the problem with applying forces. You're actually applying forces in a realistic way to objects around you. If you did jump and your foot hit that box and you're strong enough to jump that high, that box is going to go flying, right? If it's low in density, it doesn't have anything in it, it's made out of cardboard, whatever. So the problem is I fell down. So this is where you want to use a trick inside of Boxity and say rect.is fixed rotation true. Now when I do it and I try to jump, I won't fall down, right? I won't actually be affected by rotational forces. That's another way to actually make your player, move without having to worry about getting knocked down, okay? So let's make one more button so we can make him move and jump. Take that off. And we'll say jump button. Local jump button. Get button. Function. Jump right button. Just kidding. Jump button. Touch. Event. If event.phase is ended, then jump to the right. Sorry, turn true. And then listen for it. Yo, hey, when you touch, call yourself. Brr. And position this guy off to the right of the move right button. Plus, I don't know, 12. So we have some gap. Okay. So we can move right. We can push the box, right? Then we can jump and kick it. It's not what we're supposed to do. We're supposed to jump. Jump. All right. Let's increase our linear impulse of, try 150. Just gonna move the box out of the way. And we're gonna jump. Let's also change it to 300. See if that fixes it. There we go. Now he's like Frogger. He's flying. So that's the basics, ladies and gentlemen, of creating a simple Box 2D scroller, side scroller with movement, Now you're going to have to make some more buttons, obviously, for left and jump left and jump right. On some multi-touch devices, you can actually deal with jumping, left or right based on context. Some devices don't support multi-touch, and other times it's just easier for the thumbs, if they're there, to jump right, jump left. Depends on the context of your game, but that's basically the gist of what you're saying, okay? So that's making a character run and jump in a Box 2D game for Corona SDK inside of Lua. If that was helpful and you learned, you got any questions, hit me up. I'm Jester Excel on Twitter, I'm on Google+, I'm on Facebook sometimes. You can hit me up on email. Don't forget to subscribe, and thanks for your time.